and we're hitting chapter 9, and we're talking about metaphysics, which Tony's going to have to explain to us what metaphysics is, because it seems very high and above us.
Yeah, metaphysics, I mean, it's pretty straightforward, right? It's the so actually the word came from the writings of Aristotle, the early Greek philosopher, and he wrote a book about physics. Actually, I think what happened was his students copied down notes and put it together as a book. And then there was a bunch of stuff after his discussion and lectures about physics, and they didn't know what to do with it because it really didn't touch on physics and that sort of thing. And of course, the word meta in Greek can be translated, depending on the context and other grammatical things, as after, right? And so they labeled these extra things that he talked about after physics. And so we translate metaphysics. So that's where we get the word from. That's, that's the things that Aristotle talked about after he finished talking about physics, right?
The simple things like the nature of the universe and whether other people exist.
And so in the philosophical realm, it usually has to do with the study of the nature of reality, right? What's the nature of reality? How questions about God, obviously, is a metaphysical question.
Time, the mind, those things that seem really high above us and don't quite seem like afterthoughts, but if you're Aristotle, I guess you can start wherever you want to.
Right, and so what Mitch Stokes here is trying to do in this particular chapter is he's having us consider, can we have a physics-based metaphysics? In fact, that's the name of this chapter, right?
Right.
Can we base our metaphysics on the physical aspect of things, right?
Is there a kind of a naturalistic explanation that we can get for things like other people's minds, the concept of time and dimensions, and why the universe has started and been ordered the way it has? Are we able to find these answers within physics themselves?
Right.
Because we see that when it comes to general relativity and quantum mechanics, it seems like those far extremes, new science, are being built as kind of these all-encompassing. We're finding the fabric of the universe, almost literally the strings that tie everything together.
String theory.
Yeah, exactly.
Fabric of the universe. That's where that came from.
Going back to Plato himself. So, so we see we see an attempt by, I think, scientists today to try and kind of unlock that. When they come up with theories for new ideas, like the God particle, like, oh, here's the thing that's really going to drive everything together, and they find it and they're like, yes, that's great. Now here's 22 other ones that we need to come up with in order to explain, a part of our theory. And in the last episode, we talked about, 10 to the 500th power of theories, which is, I think I did the math. It's something like 4.5 times the number of atoms in the universe. That's how many theories they have to go through. So someone's at a big blackboard just checking them off. So that's what we're going to look at today. And so Dr. Stokes talks about the fact that science doesn't tell us the truth about the fundamental nature of reality, which we looked at in the past chapter, despite its spectacular success regarding the parts of the world we can observe.
Yeah, and we know this because we have the two basic fundamental physical theories, relativity theory and quantum mechanics, and yet they are incompatible with one another.
Right.
So somewhere they've gotten it wrong.
Yes,
right?
Someone's tricking us. But they're both like Newtonian mechanics. You throw the ball up, the ball comes down. With quantum mechanics, we get things on the small end of the spectrum. Quarks and the fine-tuned particles of the universe. But then on the general relativity side, we see things like stars and gravity, those things that are coming into play on the other end of the spectrum. But they don't seem to meet, and they come to contradictory decisions when they go out on those, as Dr. Stokes calls it, the branches.
Right. There's contradictory conclusions. Right. The experiments don't check out the way we would expect them to do, given a particular theory, right? Yeah, especially quantum mechanics,
because we're still all trying to figure out what that is. When it comes to the construction's behavior of matter, energy, and space-time, for example, there are good reasons, as scientists tend to either hold in private consideration or they are flat out about it, but it seems like the predominant theory is that God doesn't exist. So if they have a hard time with this type of understanding of providing us kind of the basic building blocks of the universe or how it's currently made up in the big picture, there are good reasons to doubt things that are what we would consider unobservable, those things that are kind of the paranormal, the things outside the scope that naturalism would expect to touch on.
Right. So in other words, if they don't get it quite right with regard to physical things that we can observe and that sort of thing, why would we expect them?
Yeah.
Right, from a skeptical point of view, to get it right about unobservable, such as God and demons and angels and soul and afterlife and that kind of stuff, if they can't get it right about these physical things.
Clean up your own house first type deal. Yeah.
Yeah.
So he goes on to say, science wouldn't necessarily be the most reliable source for these types of subjects. So we're going to look at whether or not that's entirely possible to even have a naturalistic physical description of what these metaphysical questions are.
Yeah. So he says, so then it seems to be a bit premature to use scientific premises to account for the origin of the universe, right? The origin of the universe, we might consider that, right, a metaphysical question, right?
Right, not just the fact that it started, well, that could be one too, but how did it start? Where did the original material come from? In what way? In what fashion did it start? There's always the attempt, things like the Big Bang, or before that the consistent state theory, that the universe that has always existed, or you have Krauss's model, which says like in a vacuum these different particles come to almost nowhere, but again, nowhere doesn't really mean nowhere when it comes to Krauss. So it's not the fact that it's at what was the speed of light at the very start of the universe. Well, it seems to indicate that it might have been faster or anything like that. It's just the fact of not what, but the why.
Right.